Good day, Antimatrix. I hope you've had a great day so far. And I'm sorry that I can't be with you today, but I'm in the process of moving house, so that's why I'm not at school today. And that's why also I'm not teaching you live online. It's about 1:15 in the morning now, so I am only getting to your lesson now, but it'll be fine because by the time you guys wake up and you're at school, it will all be ready for you. Right, so let's just recap. I unfortunately did not scan the memo of the exercise that I gave you in class yesterday. Yes. So we'll deal with that next week. That was just revision of distance formula, gradient, and midpoint. We'll deal with that next week when I'm back at school. But for now, what I want you to do is you're going to make a new heading that says the angle of inclination of a line. All right, so that's your heading for today. All right, so what the angle of inclination of a line means is that if we have a Cartesian plane, so we have our y-axis, we have our x-axis, and we have a straight line. The angle of inclination is always measured from the x-axis up until that straight line. So let's call it theta. All right, so how do you work out this angle of inclination? All right, so the formula that I want you to learn is the following. Tan of theta, and remember that in this instance I've said let the angle theta be the angle of inclination between the x-axis and the line that we're wanting to work out the inclination. So in this case, tan theta is equal to the gradient. Now the gradient of what? So if we said let this line be line AB, then it would be the gradient of AB. So obviously, if we are now working out the gradient of the straight line AB, we can, given the coordinates of A and B, we substitute those coordinates of A and B into our gradient formula for the right-hand side, and we then have tan theta equals a certain gradient. We then have to use our shift tan function on the calculator in order to work out the actual value of theta. Okay, so let's look at an example. All right, example 1. Determine the angle of inclination of, question 1, the point P, 2 and 1, and the point Q, -3 and -3. All right, so a good strategy to answering this question is to maybe draw just a rough Cartesian plane of what this looks like, just to get an idea of where you are meant to be working out the angle. Okay, so let's look at a straight line. Okay, so our straight line is going from -3, -3, so I'll put a -3, -3 here. And the other point is given as +2 and 1, so maybe about there. Okay, and that's our straight line. So because they've asked for the angle of inclination, that means it's the angle from the x-axis to the line. And we generally call that theta. Okay, so tan of theta, and remember this is point Q, and that's point P. So tan of theta equals the gradient of PQ. Right, so now we substitute in. Okay, remember the aim here is that we're working out theta because they want the angle of inclination. Right, so we substitute in what we've got. So tan of theta is equal to the gradient of PQ. Now we have to work out the gradient. Okay, so the gradient, remember, is the at the top the y value of the one point minus the y value of the other point. So let's go with minus 3 minus 1 at the top. So minus 3 minus 1. And at the bottom, we're going to go with the x values, minus 3 minus 2. Sorry, choose a pen. Minus 3 minus 2. So that simplifies to tan of theta is equal to minus 4 over minus 5, which is obviously positive 4 over 5. And we get, when we go into shift tan, that theta is 38. Sorry, I can't see my calculator. 66 degrees. Right, so let's look at the next example. So you'll see in the next example, something exciting happens. I know how you guys love exciting things that happen in maths. And the best part is, because it's a pre-recorded lesson, I can do my normal dad jokes and you can laugh, but I don't hear you laughing, so it's fun. All right, so example 2. All right, so for here, example 2, and if it sounds like I'm irritated, it's because I recorded about 5 or 6 minutes of the lesson and suddenly realized that it actually wasn't recording, so I have to do it again. Okay, so, but I'm not irritated, I really am not. All right, don't worry. All right, so example 2. You have to determine the angle of inclination between the points M and N, M negative 1, negative 1, and N 5 and negative 4. Okay, so the idea is that first sketch it, and I'm going to show you why, particularly in this example, why you sketch it. Okay, so a rough sketch, guys. You're not marked for your sketch, so it's fine. So M is negative 1, negative 1. That's somewhere here. We don't even have to put the coordinates on the diagram. And then N is 5 and negative 4. So that's maybe about here. Okay, so you actually end up having a negative graph. I'm OCD, sorry. I think I've told you. Okay, so see, I have to make that look straight. Sorry, girls. Okay, it's a bit straighter. All right, I'll look at it squint and then it looks straighter. Okay, so we're working out that angle of inclination. Now, I told you that the angle of inclination is between the x-axis and the function. But now, this function doesn't even touch the x-axis. So what we can do to illustrate how the angle of inclination works is we can extend this line through the x-axis. And then the angle of inclination would be that angle from the x-axis until the actual straight line. Okay, but we're going to use the formula. All right, so the formula is that tan of theta equals the gradient. And that's exactly how the formula is given to you on the information sheet. Okay, so let's label our points here. So the point M is negative 1, negative 1. And the point N is 5 and negative 4. All right. And now we're going to calculate the angle of inclination. So the angle of inclination is what I've shown you in green there. Okay? But you'll see something slightly different happening in this example. Okay, so let's do it. Right, so tan of theta is equal to the gradients of the line. So the gradients of the line is the y values at the top, subtracted from each other, over the x values. So if we start with that y value, minus 1 minus negative 4, that actually becomes minus 1 plus 4. Okay, and then if we go to the x values at the bottom, because we started with this side, we must start with that x value. So minus 1 minus 5 is going to become, well, choose the pen, minus 1 minus 5. So simplify that. Minus 1 plus 4 is positive 3, and minus 1 minus 5 is negative 6. So in actual fact, in this case, and remember we need to work out the angle theta. So you're going to use shift tan, and you're going to put 3 over -6, and you're going to end up with negative 26.57 degrees. Well, that's a terrible 5. Okay, I'll redo it. How can we have a negative angle? That's weird. All right, let's look what happened. Why do we have a negative angle? Because when you use shift tan, your calculator does something weird. Okay, your calculator decides, I'm going to use another color now. Your calculator starts over here on the x-axis, and it actually finds the shortest distance to your graph. So in other words, instead of going in this direction, you know it goes from 0 degrees to 90 degrees to 180 to 270 to 360. Instead of going in that direction, your calculator thinks, hang on, the shortest route is actually in this direction. Okay, so it goes in a negative direction. All right, so what that means is the calculator has shown that it's moved negative 26.57 degrees. So that's what that represents. Okay, but we don't want a negative angle. We want a positive angle. So in other words, this straight line that you can see me moving my cursor from left to right has the same angle of inclination anywhere it is on the Cartesian plane. Okay, but if we've got a negative angle, so in other words, we've moved from the x-axis where x is 0 degrees, and we've now moved 26.57 degrees in a negative direction, how do we make that positive? Do you see that if we add another 180 degrees, we would actually, from this point, okay, sorry, my Apple Pencil died at that point, so I had to stop for another 5-10 minutes to charge it. But what we were saying is that at this point, we've now moved negative 26.57 degrees. If we add 180 degrees, so now remember with your angles in trig, angles are measured positive in a clockwise direction, because we know that at this point is 0 degrees, at that point is 90, that point's 180, 270, 360. Okay? But negative angles go in the other direction. But if we're at this point and we add 180 degrees, we actually end up back on the same straight line. How amazing is that? Okay, so effectively, and I'm going to repeat what I said earlier, your calculator works out the shortest distance from the x-axis to your graph. So in other words, whenever your graph has a negative gradient, that's normally what's going to happen. Your calculator is going to give you a negative answer because it's gone in this direction. Okay, it's gone from the x-axis, where x equals 0, to whatever the angle is, in this case, negative 26.57. Okay, so you need to add 180 degrees, and then it gets you to a positive angle. And look at where the positive angle is. That now would show you this angle. Okay, from the positive x-axis to the actual graph. Okay, so let's look what happens in this case. So we've got negative 26.57. So we then know we now need to that add 180 degrees. And we know we add 180 because the angle's negative. And we get an angle size once we add 180 of 153 degrees, 43. Okay, and if you look back at the diagram, that makes about sense, that this angle would be 153 degrees, 43. All right, example 3. Determine the angle of inclination of the line 2y equals 3x plus 6. Okay, so now we haven't given you a diagram, but we've given you a function. So the first thing that you need to do is to put the function in standard form. And remember, standard form is y equals mx plus c. Okay, so the way they've given us this equation, we really have to just divide through by positive 2. So we get y equals 3 over 2x plus 6 divided by 2 is 3. Alright, so in this one, we don't need a diagram because they've asked the angle of inclination. So I'm specifically not drawing a diagram because I don't want to show it to you. But imagine this is a straight line somewhere. And the angle of inclination is the angle that the straight line makes with the x-axis. So we can straight away say that tan of theta, if theta is that angle of inclination, is equal to the gradient of the graph. And the gradient of this graph is 3 over 2 because that's the m value. Alright, so tan of theta is equal to 3 over 2. And then if we use shift tan and we put 3 over 2 into shift tan, we get that theta is equal to 56,31 degrees. That's the angle of inclination. And it's positive, so we don't need to add 180 or whatever. If it was negative, we'd add 180. Because remember, as I explained to you, if it's a negative angle, it means that the calculator has worked out the angle from the x-axis in a clockwise direction or a negative direction. In other words, the shortest point. But we want the positive angle. Okay, aunties, I'd like you now to do exercise 4.2. And that's on page, I'm just looking now, sorry. Don't even know. 74, I think. Yeah, 74. But I only want you to do all of A and all of B. Okay, so with B, I want you to think a little bit logically about how to do that because I've not done an example exactly like that, but I want you to use what I've taught you to work out the answers for B. Okay, that's all for today. We're going to do another couple of examples the next day, and then we'll continue more of exercise 4.2.